conferences. He had featured at most cited information system in the world ranking of top 2% scientists created by Stanford University USA 2020. He has received numerous number of awards. Some of them are Outstanding Researcher Award in Energy Engineering from STAR Awards 2021, Outstanding Scientist Award 2021 in the International Scientist Award on Engineering Science and Medicine. He Distinguished Scientist Award 2021 in the International Scientist Award on the Engineering Science and Medicine from Professional Association. Rashtriya Gaurav Award 2017 from Indian International Friendship Society. Last but not the least, Commendable Research Award 2019 for publishing a quality research paper in DTU, Delhi. Now over to you, sir, please.
Thank you, Shubhaditya.
Yes, thank you so much, sir.
So this session is Professor Shekarkar on geothermal energy was supposed to handle, but unfortunately he's having some other work, so he couldn't able to join us. So I will be served as a Stepney. Now the function of Stepney, as you know, right? So I will talk on the solar drying systems, and before that I will just highlight some of my work. Actually, 2 years I have passed as a postdoctorate fellow in 2015 to 2017 in Thailand. So there I got chance to work on the rubber drying systems, right? So we have developed some technology over there, rubber drying system, and even the government has accepted that technology. Okay, so that one, just a moment. So we will have some discussion on that, and natural rubber basically. So Thailand is the topmost exporter of the well-known country for this natural rubber. Thailand, Malaysia, Indonesia, and then India and Sri Lanka. Okay, so these are the 4, 5, 6 countries. So they captured almost 98% of the international market of this rubber technology. So okay, yeah, this one. So development of high efficiency natural rubber sheet smoking rooms. That first I will talk about this. Then I'll switch over my talk on the solar drying system. So I'm working on the solar drying system for developing energy efficient solar drying system, cost effective solar drying system, and in fact we have one patent also on that, the greenhouse drying systems. Okay, so few books and few research paper, good research paper, which are having the good citations, come from my lab. In the past, I have spoken in the past few years, right? So, actually, as I told you, in 2015 to 2017, I was in the Prince of Songkhla University, and that in the southern part of the Thailand, in some government project, I went there. Right, so there we have developed some rubber drying system, basically rubber drying rubber, and this is called basically rubber sheet smoking room. So for the heating purpose, or the for evaporating the moisture contained in the rubber sheet, it is a lattice basically, right? It is this is all. Yeah. So this is basically sheets are made. I will discuss with this process, the complete process. This is this tree, Hevea blenensis, and this bowl we kept in the morning and just collect after 3-4 hours. Okay, so the capacity of this bowl is the 250 ml. It drop by drop and collect over this snowball. Okay, so this one is this is a natural rubber sheet plant basically. Okay, you like the Adda sleepers, okay, very much famous Adda sleepers, natural rubber sheet itself. But there is a lot of frauds are also there. Many this rubber sheet items are not prepared by natural rubber sheet. Artificial rubbers are also there. So lot of things made by this tires, seals, coupling, bridge and building, buildings, footwears, hoses on this conveyor belt, mold product, linen, roll, globes, and many other medical products, right? Adhesive, carpet, thread, a lot of things is are prepared from this natural rubber sheet, and this is a biodegradable. This the best thing is this is biodegradable, and it is not harmful to the environment, right? And the common practice for the drying this sheet is just the burning the fresh or the young branches of this rubber tree plant itself. So the fuel is the rubber tree plant, some young branches that are first dried under the open sun drying condition or greenhouse dryer. We proposed one greenhouse dryer over there to dry these branches, so that so that efficiently the combustion, the heat of combustion can be used efficiently. Okay, so this smoke, basically the smoke generated by the combustion of these plant branches are supplied into this what is called this smoke room. That is the smoke room. Okay, so some traditional models were there. They were not so energy efficient, and of course because of that, because of the drying in the southern part of this Thailand, a lot of industry, lot of this cottage industries are there, and the cooperatives are there, in fact. Okay, cooperatives, some villages are come together and they form some cooperative. That means small farmers, they collect this lettuce and just deposit over there in this cooperative for the further processing, like in that way. So that is the process. So about the 8 to 10 million tons of the rubber are produced in the world, and Asia is the main source of the natural rubbers, accounting for the 94%, but it is more than that. Okay, so main this natural rubber producing country is number one is Thailand, then Malaysia, then the Indonesia, then Malaysia, India, then Sri Lanka, like that. And we have also the rubber board in the south, in the Kerala part, Kerala and this Tamil Nadu coastal area, you know, a lot of this rubber tree plantation is there. Okay, so that work, actually this is the process. The manufacturing process of rubber sheet is step one, the collection of the fresh rubber latex. Collection is there. Then coagulation of the fresh rubber latex using the formic acid and water. So formic acid we add to settle basically, and and also we need to remove the bubbles from there. Okay, so continuous stirring process is needed over there for the removing the bubbles and all. So if suppose the bubbles in this rubber sheet, it is not means the cost of the rubber sheet is reduced. Okay, so because of some rubbers bubbles, some stiffness is there, and from that area the crack after some time. Okay, so it becomes brittle basically. And this formic acid for the for settling this latex. The forming lumps of the this coagulum, and after the 3-4 hours, so they insert basically they insert separators. Okay, if you can able to see, these grooves are there. Okay, along the side, and same this one, and these separators are inserted, so that this separator, this person basically, just look at what this is inserting this separator, so automatically the sheets forms. Okay, and now the squeezing and hardening the rubber from the thin sheet, because squeezing for removing its initial moisture. So whatever the after some time, this rubber sheet is passing through these wheels and the squeezer basically. This is the water squeezers. Okay, to form the thin sheet, and then for few hours, the 3 to 4 hours, these rubber sheets are hang under the sheet. Okay, so that the water is removed in the form of the droplets and all. Okay, so hanging the rubber sheet on the card, then later on these cards are inserted into the rubber smoking rooms. Okay, you just see this is rubber smoke. This is the supply duct at the bottom. Okay, and the carts are moving on the rail track. Rail track is there. Okay, so many carts at a time, generally in the smoke room having the capacity of 800 to 1500 rubber sheets at a time, they can or more than that. Okay, that depends. And in fact, the major challenge of this rubber sheet drying is uniform distribution of the heat as well as the airflow should be there. Okay, uniformity must be there. Otherwise, what will happen? The some sheets dry very early, and in fact, the moisture contains of the rubber sheets again a very important thing. Okay, so initial moisture content is around the 37 to 39% weight basis. Okay, so now this was the conventional model. Conventional model 1994. My mentor, Professor Perapong, actually, he has worked on the during that time numerical simulation modeling. He has done. He's a PhD from USA. So Professor Perapong developed some model. Okay, to to develop means he has done basically first the simulation modeling for the conventional type smoking room, rubber smoking room. Okay, so those conventional models are known as 94 model and 95 model. They're based on the passive and active type circulation. So the difference between these two models are in the size of the room and geometry and arrangement of the hot gas supply duct. And these are the hot gas supply ducts. Okay, so through the simulation, what he did, he has done, this uniform distribution of air and temperature must be there. Oh, between for the proper drying of this rubber sheets. Okay, so capacity of the 94 model is 1.3 tons, and about the 3 tons in 95 model, just double. Okay, so this one is a huge capacity, this one. And so basically the computation simulation modeling was done to predict the temperature variation, and there was the variation. The temperature variation was 15 degree centigrade. Temperature variation was from some part to the another part. Okay, and these are all the chimney and outlet ventilation lid, and totally this is the passive based. Okay, because of the thermosiphon effect, and this is the furnace. And what happened, and this is just to see, this is the taper side, because the flow is maintained to try to maintain in the passive condition. Flow is try to maintain with this duct, with this shape and chimney, and the opening and closing of this ventilation and outlet ducts. Okay, so these are basically so that this is basically based on the experience, and this rubber sheet is very sensitive. Okay, and if suppose it is over dried, then definitely it is no more use, no more of any kind of use is there. So okay, and lot of wastage was there by that time. What happened, the furnace was outside this room over there, and simply this most of means young branches of this rubber tree was burned, or combustion was taken place over there, so that the hot smoke is supplied. Hot smokes are supplied through this duct, okay, through this channel and through these ducts. And basically the main thing was to arrangement of these duct, right? The proper arrangement to maintain its uniform temperature, and the flow in between this, how, because in the card you can see these are very much close to each other. So this was the main task. Okay, so result of the less than the optional design of smoking room, especially hot supply ducts and the ventilation, which causes the non-uniform drying and the poor thermal efficiency of drying system. So that was the initial in the 1994 model and 95 model. This was the initial condition. So okay, so because of that reason, almost the 15% rubber sheets are become waste, because overdried, sometimes it is overdried and the color is changed, so no more in use of no more any use in the product making. Okay, right? So so now actually he is a leader, and I was the part of that up to this portion. I was part of from actually I have been long time association with him. So from 2007 to 2016 I was associated with him, and later today also, but not in that much of active. But so actually what he has decided from 1994, whatever the knowledge he has acquired in the 1994 and 1992, the simulation modeling, CFD modeling, these were just a dream, and in fact in India it was a dream totally. And very rarely the researchers were working on the simulation model and computational design, right? So but he has a strong means command on the simulation modeling and all. So he, whatever he has learned in the USA during his MS and PhD, and he applied in his country. Okay, so so now, so it was the basically it was the design based on, this was conventional design, and some improvement was done based on the experiences only. Okay, so this journey was started in 1994, and then this 2007, the natural convection rank of the 1.5 tons means some improvement was there, because this improvement, there's some uniformity in the distribution of this duct, hot duct, and the ventilation ducts were designed. And this design was done in the computational software, the CFD itself. Phoenix, by the time in long back, the Phoenix was started by the time. Okay, so but later on, what he decided, because natural circulation, and in fact, what happened, and by in long back, in 1995, 1996, basically in their villages, the electricity might not be there. So totally they were dependent on the passive thermosiphon effect only. Okay, passive type of this rubber smoke rooms were there, right? And then later in the they have designed this the force circulation for the same capacity, for the same kind of systems. They have designed the force convection based. And for the force convection, definitely there's some pumps and ducts and some arrangement, and it is becomes a bit expensive, right? But by doing so, the wastage of this rubber sheets were reduced, drastically reduced. Okay, and the force convection of the then further he has moved, and in fact his research team has moved on the higher capacity. Okay, and then still the work almost, this task is over in the 2020, and because the force automatic convection, because what happened, I will discuss you later once when so this was, so automatic force convection type of system. So just see, from 1994 it was a conventional system. Now it is very upgraded things. Okay, and this wood consumption, okay, wood consumption is reduced. And as we all know, in Delhi, in the month of the October or November, some smoke problem is there, and that is smoke problem because of this agriculture residue is burned in the newer states. Okay, so the same type of situation was there. Indonesia or the southern and nearby this country in the Malaysia, they were just firing their this palm tree or the palm forest okay, for the cultivation of this rubber tree and all. Okay, so because of that, so that because this wind direction was towards the southern part of this, so huge amount of the smokes, and because of their own burning of this biomass, such kind of the problems were there, air aerosols and all. Okay, that was the real work, whatever the development has been done there. And now these are the basically this is the this is the Parapong name. Basically this rubber model has been given with the Parapong name. Okay, so this RSS rubber smoke sheet rooms in model this model 1 and model 2. Okay, so this more uniformity is there. Then this is the force circulation, and and now the latest model is this one. Okay, so development of the high efficiency rubber smoke rooms in the prototype. And now let us have a discussion on this kind of system. So this system was this room dimension is 2.56 meter and 3.5. Okay, so so heat and smoke generated in the fuel wood by the natural convection. Hot smoke supplied through 84 and 50 mm. These are the 84 holes basically. Okay, 84 holes or the 50 mm diameter of the hot day, and the humid gas is removed through the 8. These are the 8 to 0.2 meter by 0.2 meter. There's a ventilation lid at the ceiling. Okay, so this one. And this is a specific energy consumption. It's a specific energy consumption. Of course, here it matters, and the efficiency of the drying. So this is simply the moisture evaporated and the whatever the fuel consumption is there, the heating value of the wood, heating value of the natural wood only, and the quantity of wood and the retentive of vaporization, and this is the quantity of the mass is removed. That's all. Okay, specific energy consumption. So now this conventional rubber smoke room, the temperature variation was in the beginning, in the starting, it was 15 degrees centigrade, right? And the specific fuel wood consumption, the kg per kg dry rubber sheet, was the 1.26, right? And the specific energy consumption was the 34.3 megajoule per kg of the water evaporated, and efficiency was 6.9. Now just see the okay, now just see this is the developed model. Okay, so RSS room model 1, the temperature variation was only the 5%. Specific fuel consumption is almost the one third. Specific fuel wood consumption is almost the one third, and the specific energy consumption in the per kg of the water evaporation, just look at over there, it is almost the half and lesser than half, and efficiency becomes doubles. Okay, 7 into 2, the 14%, more than doubles. Okay, and this paper we have published in the Performance and Economic Analysis in Natural Rubber Sheet Drying covering Renewable Energy Journal in the 2019. This work we have published, right? And these were the basically the variation of temperature at the front, middle, and rear plant. So this one is the front, rear, and middle plant. Okay, these are the variations. So just to see, the variation is not much, not more than the 5 degrees centigrade. Okay, so that we want for the improving the quality as well as to make the system energy efficient, right? And the purpose of the energy efficient, to making the energy efficient means we need to improve the combustion efficiency. That's all. Okay, so combustion efficiency, better utilization, so therefore the system becomes more sustainable, and at the same time the environmental degradation was not there. And definitely, and Professor Parapong is associated with the have aerosol. Basically, he's also the aerosol expert. With the collaboration with Japan, the Professor Hata and Professor Furuchi, they are the very renowned person in the aerosol technology. Okay, so they control such kind of systems, such kind of problem, and basically they reach the root cause of that problem, the smoke problems, right? So now, just to see, this is Sankey diagram of this one. Okay, Sankey diagram, modified rubber smoke sheet. So total energy input is a 6,213 megajoule, and how it is distributed. This is basically this one is this you can consider these are the losses. You know? So losses, the conductive losses, and also some leakage are also there. And because in the first development, this insulation was not done. Okay, and even some gaps are there in the front view. Okay, some gases are there, and of course these losses are much more, but because of the natural thermocycline effect, or because of natural convection condition, we cannot control, we cannot lower, we cannot much lower these kind of losses, right? So now the rear wall, left wall, right wall, and door, some leakage are there over there on the door, and that's from the ceiling it is highest, because for the proper movement of the hot smoke inside the room, that means of course it has to be escaped from somewhere. Okay, and this much is only the utilization. We are supplying the 6,213 megajoule. Okay, and it was calculated with the combustion of the fuel wood only, the heating value and the mass of the total mass of the wood is consumed. Okay, so based on that, so used one is only this one. So the used one means how the used one, basically this is the latent heat of vaporization, the mass into mass of the evaporated and mass of the initial weight minus the final weight and the latent heat of vaporization. And as we know, latent heat of vaporization is of the this for the evaporating the moisture is 22,260 kilojoule per kg, right? And of course it is very huge. And okay, so so now the total input from this fuel wood is this one, 6,200. The energy loss from the sealing highest, 67% energy loss from the removal of moisture by the opening and ventilation. So in natural case, it is quite obvious that this much, definitely the losses to the wall and the door by the conduction 31.9 and 1.1%. From the door is less. Okay, energy used in the evaporating moisture on the rubber sheet is only 15.7%. Earlier it was 6%, right? So earlier it was only the 6.7%, but now because of the proper designing, the energy consumption or the fuel wood consumption is reduced, and of course it impacts a lot on the economy, in the local economy, right? Because of the local economy, because cooperative, all the villagers are there. Okay, small farmers are there. They are collectively run this one, and finally whatever the production of the rubber sheet is, then they are supplied to the respective industry, right? So, and the cost of this smoke rooms is very high, and they are of course means it is beyond the capacity of those local on the poor farmers, right? So this is the collective work, or for that reason the cooperatives are formed, right? So now this is some simple economics, nothing there is no such a very nuclear science or something which is not we able to understand. So let's look at over here some economic analysis. Okay, so this economic feasibility of the modified this smoke rooms was based on the assessment of payback period. The simple payback period, the total investment, this is the maintenance and initial investment or construction material and the construction or the labor cost. Okay, labor cost and the construction materials, that's all. Okay, and now, yeah, instead of this, this is the this is conventional method, so nothing much. So just look at over here. The investment cost for the construction installation of that kind of natural rubber sheet dryer smoke room, 8,000 USD. Repair and maintenance is 1% of the investment. So it is like this. The drying time is 3 days, because what it takes some time, because you cannot the drying of the rubber sheet starts from the 35 degrees centigrade. Okay, 35 and 40. Then they slowly they increase its temperature. Okay, increase its temperature means the consumption of the fuel wood is increased slowly at some stages are there. Okay, otherwise the bubbles will be there. Okay, and once the bubbles in the rubber sheet, it will no more any of use. Okay, so that means that initially the drying is taken place the 40 degrees centigrade, then the 45, then the last one is the 55 degrees centigrade. Okay, so this drying of the rubber sheet takes place in the 3 stages, and it is very sensitive to the temperature. Okay, so okay, fine. So fuel wood consumption was the 42,000 kg per year. Price of the fuel wood is this much, and drying cost this much. Price of the rubber 1.6 USD per kg. Price of the rubber sheet drying sheet is this much. Amount of to dry the material, the 100 tons per year. Okay, interest rate there in India it could be the higher than 1.5, and discount rate is 7%, and expected life for that system is 20 years, right? So net annual cost saving is 1,413 USD per year, and payback with the payback period of the 5.7 years, right? And by that time, this work was done in 2017. However, it was published late, but in 2016, that work that was the estimation of that thing, economic analysis was done. So 1 USD equal to 35.4 Thai baht. Okay, so that was the cost. Then the later on, this is the another model. Okay, so in this model, the size is increased. The room dimension of 5 meters, 6.5 meter, and the 4 meter. The hot smoke supplied. Here the 80 ducts of 50 mm diameter hot air ducts, and the eight one this ventilation port in the front. Okay, this now just see the geometry has been changed, because see okay, so actually these all the design has been done. This designing of the positioning or the location of this duct was done in the simulation software itself. Okay, so 2.2 meter 0.2 meter by the 0.2 meter ventilation ports in front. Okay, this one front, and 0.5 at the back of the ceiling, with a capacity of 3 tons. For the now the capacity is just double. Okay, and this was designed in this way. And again, is a tapered, and the duct was tapered in this way, because of course the temperature of the hot smoke is higher at this point. And definitely we need the lesser duct at this place. Okay, lesser ducts, and so flow rate of the hot smokes must be lesser than as compared to this. Okay, because by the time when it reaches at this end, definitely its temperature get down, and when the flow rate, so to maintain the flow rate must be higher as compared to this. So because of, so the duct inside duct arrangement was arranged, and accordingly this the position of the duct in our previous, if you remember, these were the uniformly distributed. The 4 is there, 4 is there, like this. So total ducts were there. Okay, so by changing this, first the simulation study has been done, and these are all the pictures inside the these are the different ducts. This is at near rear wall. Okay, near to the furnace. Just look at over here. There is no duct at this side. Okay. This is the cart, and empty room, cart again, and is loaded. The carts are loaded with these rubber sheets, and this is the furnace. Okay, backside. So from there, this was basically the concept of the forced convection rubber sheet drying. And over there, then again, because earlier what we were doing, the exhaust were directly escape to the environment. Okay, and in fact its temperature was higher. Of course, its humidity was there. It is hot and humid here, but it is having a lot of the heat energy. Okay, but so means if suppose this hot air is having the 60% or more than relative humidity, definitely it will degrade again. It will degrade this quality of the rubber sheet. So in the beginning or in the initial hours of the drying, we do not recirculate. Okay, so this recirculation concept has come. Okay, then definitely it was again these are the common practice, and anyone can apply, but it was done on that side. That matters, and people have adopted, and in fact in the lab it was adopted with the recirculation, although recirculation is not so means a new thing, of course. So by doing so, the concept of reducing the drying time and the forced circulation, and I will show you the result. The drying time, as drying time is lesser, that means the fuel wood consumption is lesser, right? Stop this. Okay, so and one more thing, yeah, I forgot to, yeah, in this concept, because what happened during the squeezing, if you remember, in the for the fabrication or the manufacturing of rubber sheet, one process was squeezing. And in this squeezing, the water from squeezed water, and earlier that squeezed water was just drain out into the this drainage. Okay, but later on in our team, one researcher has realized why we are draining this water, and this water we can use for the biogas production. And you will not believe, I will show you in the later part of my slides, that water was collected and just covered, and the water was collected near one pit, was one small this space was made for this collection, and covered with the rubber sheet only. Simply we have covered that small pond, you can say small pond, a small storage of this squeezed water, and just covered. And you will not believe, the after a few days or the 30-40 days, the biogas, we have not done any nothing, no technology, we only just collect and cover, and biogas generation was started. And that biogas has been used along with this firewood, right? So in this concept, two things were there. One is the proper circulation, the forced circulation was there, for means the proper air was circulated in between the rubber sheets, okay, so that the temperature is maintained, right? And because of the proper designing of the lids, the ventilation lids, and this duct over there, okay. And another thing was the squeezed water was collected in a pond, a small pond, and biogas, the generated biogas has been used in the for the purpose of this flame, okay, for the purpose of supplying the hot smokes, okay, firewood, right. Now, and this one this one is the third model. The room size is 2.56 meter, and 3.5 meter height. The hot smoke supplied in 80 and 50 ducts, hot air inlet, the four 0 0.2 and 0.4 ventilation port in the front, and one at the this much of size at the back, okay. The hot air mix with the fresh air and recirculate in the gravity of the settling, the mixing the chamber, and then pass to the two boilers, okay. Two boilers were definitely, and the boilers are running with the this conventional energy, of course. It is expensive, but in overall it was economic, okay. This much, and capacity was only this for that model, the capacity was 1.5 tons. 1.5 tons means one rubber sheet having approximately 1 kg, okay. 1.2 meter is the size, 1.2 meter square is the size of this and what is called this and the weight of this rubber sheet is 1 kg, okay. So that was the third development. And conjugate heat and mass transfer modeling was done by one of our research scholar, the Racha. And I was also, fortunately, I was also that team and the part of the team on the continuity and momentum. This equation, these are all the energy balance equation and all this energy modeling equation in the CFD. So okay, so and the conjugate heat and mass transfer modeling was done for that purpose. So a new rubber smoking room has been designed, a better temperature and the flow distribution for the computational analysis. This modeling was done in the 2017 itself, and this work was published in the Applied Thermal Energy, and one of the best journal in the this elsewhere, okay. So so in that the conjugate heat and mass transfer modeling, so just look at over here, the after 6 hour, uh, 24 hour, 36 hour, and 48 hours, okay. So airflow is streamlined inside the smoking room. It was definitely some turbulence and some irregular phenomena was there, of course. The temperature profile in the room, that was the 70 degree centigrade was reached up to that point, but however the 70 is not desirable. So okay, the moisture content profile and the rubber sheet during the drying. So this one, fine. These are the some results, and just come to this point. Okay, rubber sheet model, this one. So now, oh yeah, yes. Now just see this the total period of rubber. The half condition means half loaded. Half loaded means the 1500 sheets were loaded there, and this is for the 3,000 sheets were loaded. Okay, the full load condition, half load condition. Now the power percentage of the low quality. Just to see the percentage of low quality. But in the beginning, the percentage of the low quality rubber sheet was up to the 10 to 15%. Now the it has reduced. Of course, there is some because total the 100% best quality you cannot produce, because definitely and fact is this rubber sheets and this latex are is very much sensitive. If suppose some even the in some particular time, if suppose the temperature or surrounding air is more than the 2 to 3 degree, definitely it will degrade. Okay, bubbles are there, many things are very sensitive this rubber sheet. Okay, so drying hours of 42 hours, where the full load condition 40 to 48, the better. Of course this is the better than this, right? The specific fuel consumption. And now you can see the in nutshell this dryer efficiency at the half load condition. Of course it is not good, because of large size, large capacity, or in the large capacity it is underutilization of that smoke rooms that is used. Okay, and of course the full load condition force mode it, and I'm talking about the force mode, it efficiency is still reached 14.3%. In case of the natural, it was the 15%. And in that, let me read this thing. And this work we have published in the Energy in the 2017. This work. And so hot air inside the rubber smoking room were very close to uniform and with maximum 6.75-degree temperature variation, right? New smoking room is able to reduce the moisture content 35, this is the 35 initial, to the 0.5 dry basis within the 48 hours, right? New rubber smoking room is able to reduce the drying time by very much, 24 hours, with the 55 percent saving in the fuel wood, and 99% of the good quality of rubber sheet as compared to conventional. So this was the achievement basically. The maximum thermal efficiency was the 14.3 and lowest specific efficiency was 16.2 megajoule, and this much. All right, and now look at over there, the new smoke room can shave up to this much of rupees, 4,377. For big industrialist, it seems very small amount, but definitely for the blazer, okay, a small village and poor farmers, this is a very huge amount for them for saving of this. Okay, and the cooperative and their local government is supporting for this. And you will not believe, the same model was directly adopted by Thailand government and cooperatives, and government has supported the cooperative to adopt these models. Okay, so this with the internal rate of return the 24.6%, and the net payback period is the four years. So within the 4 year, the all overall whatever the investment is there, it will be recovered, right? And this work we have published in the Energy. It is another one of the best journal for the such kind of the work for the energy aspects, and with this. Okay, so now this is in the later this the fourth model. It was the fourth model, and capacity of the 3 tons was tested. It is means gradually means the better design as compared to previous one. Okay, so again this flow was maintained. Okay, and this furnace earlier, just you might have noticed this furnace was not proper. Okay, so later on some insulation, some proper insulation was done on the duct and the supply duct, and to reduce the heat loss for the proper utilization of whatever the biomass energy is there, for the proper utilization, right? And then we did some energy and exergy analysis based on that. Okay, so that energy and exergy analysis we have done, and and there were the many cases, 6 cases based on the moisture contents of the firewood, and the 60%, 40%, this much. Okay, this was the moisture content, inlet velocity, drying time, percentage of the good quality product, the 100%, this one, the overall specific energy consumption of the water evaporated 6.8. That was the minimum basically for this condition. This was basically this, it was optimized way. The dryer efficiency reached 33.3%. Now just look at in the back. Earlier the natural, this conventional system was having on efficiency was 6%. Now 6 to 15, then 15 to 33. And these are not any simulation data. These are the fact based on simulation, simulation design. The smoke drying rubber smoking rooms were constructed and tested for the real conditions. right? So suitable velocity was the 14 meter per second. The rubber sheet moisture contained was about the zero point 0.4 dry basis within the 39 hours. Earlier, the time was taken the 55 hours. Okay, and now that is the 33 hour less than the conventional. The more than 55 or the more than 55, the conventional, the less than the 33 hours. So it means it makes more energy efficient, and the fast drying was taking place. Okay, in the same system, the system was improved, improved in such a way. Now the concept of automatic fuel supply, this was means by 2020 it was half of the work has been done, because of the corona, some hindrance was there. It was almost about to complete basically. Okay, so over what happened in the auto feeder, in the earlier design, what we were doing, it was the manually we were feeding. Okay, by the temperature sensors are kept, we kept in the different position of the smoke room, right? And then based on the temperature and a number of after number of hours, okay, 24 hour is this much, or 24 30, means, so we based on experience, in fact, this biomass was supplied. Okay, but now based on sensor, the relative humidity, what the temperature, relative humidity, based on that the supply, the auto feeder was there, is there. Okay, so that is now more the auto force convection rubber sheet drying. Rubber sheet is rubber smoke sheet room is now functioning over there. Okay, so journey was started in 1994. Now it is fully developed, and of course this is the undergoing experiments. Team is working over there, the feeding, then this conveyor belt, and just supply with the conveyor belt, and all the auto feeders are there. Okay, that work was in progress by the time, but I'm not in. I think it was only the experimentation was remains left in the by the 2020, right? So this was all about the rubber smoking room. So if we have some discussion, then it's fine. Otherwise, one another topic is there. I just want to have a discussion on some drying system for the sustainable development. As we know, drying the means solar drying, right? So this some advanced solar drying of the food. One more, just a moment. Before that, starting this drawing, I just want to show you something. However, on that day, I have already discussed, I believe I have already discussed this economic feasibility of the solar thermal system in the topics. So, so this some initiative has been taken with by the different country. In fact, on the topic country where the solar energy is available. So, solar drying and solar energy being utilized for the food industry. And on that day, if you remember, I think on the first day or the second day, we have discussed like the solar thermal technology for drying purpose, for drying or some industrial processes. Okay, or in fact for producing the process heat applications, basically the solar thermal systems. So right, so this is the economic feasibility of the solar thermal system in the tropics. Just to see over here, we shall this is the levelized cost of energy and all. Okay, so India, the parabolic tuff collector and fractional parabolic concentrator have been used in the dairy industry. Okay, and on that day we were discussing about the dairy. In dairy, the maximum operating temperature was at the boiler, and boiler was working at the 95 degrees centigrade. Okay, to achieve the 95 degrees centigrade is not a big task. With the help of the parabolic tuff collector, or with the help of the vacuum type collector, we can easily achieve. That's right. So just to see over there, this much of rupees per gigajoule without the storage, and this one with the storage and discounted, the payback period is 17 and 24 years, right? So now the type of the solar collector installed, the various type of solar collector, flat plate collector, evacuated air collector, unglazed, parallel, parabolic tuff, fractional type collectors are being used in the food industry for the different in a different food industry. Okay, beverage and food industry. So solar collector installed, just but the maximum share is from the flat plate collector. The reason is because in the food industry we need only the temperature of in the less than the 100 degrees centigrade most of the time, 100 less than 100 degrees centigrade. So to provide for so this flat plate air collector, flat air heating collector are sufficient. Okay, and in fact it is much uh, economical. Okay, much economic viable as compared to others. Okay, the cost of the such kind of flat plate collector is very much lesser than the vacuum type collector or the fractional or parabolic type. Okay, if suppose the parabolic is there, and the one more specialty with this flat plate collector is however, if suppose tracking is there, then it is better. But if suppose we have not done, it is fixed type and tracking is not done, then it will work. Okay, but in case of the parabolic or parabolic tuff collector, definitely it needs the trackings. Okay, so a vacuum tube is also another good option. Okay, so 38. Now this is the area and power versus the different industry. Okay, install collector and the install thermal power. Okay, so this difference we can see very easily: the collector size estimation, the thermal generated for the thermal project food industry. The very much clear with this figure. So this solar thermal is sufficient for the food industry. And now the installed solar collector in the food product manufacturing. This is a very success story basically, because people are now believing on the solar thermal energy and the implementation of solar thermal in the food industry. And okay, we are a poor India and the developing country, not the poor developing country. Fine. Indonesia, but in case of the Spain, Netherlands, and USA, they are also adopting. Just look at over here. That means in the food industry, the air collector, flat plate collector, parabolic, this all. So temperature range is this much. Gross area and the estimated cost and the storage volume is this one. So now just I mean to say, I just want to show you over here that not only the developing country, the developed country also adopting these kind of opportunity to reduce the load on the to reduce on the burden on the on this fossil fuel or the environmental degradation, right? So that thing, to install solar collector for the dairy product in the different country. And this much in India, the BG Chitale, another collector, the Dosa Milk, Hastam, HB, Mahananda, Milam, and Mother Dairy. Now just come to the Mother Dairy. Mother Dairy in India, in Delhi. Okay, the temperature range is 90 or this, and the gross collector area is this one, and it is nicely working over here. Just okay. So now this one is for the installed solar collector for the processing and preserving solar fruits and vegetable. Okay, the flat plate collector evacuated and all these are being implemented for the various juice industry and the food processing industry. Okay, and vegetable and all for the drying purpose, and most of the time the drying purpose air collectors are being used for the flat plate or evacuated collectors. So now based on that technology, or without the collector, just for greenhouse, just I'm going to discuss, and some advancement is there. So overview thermal energy integration concept, application, supply, and the process, and that's all. Okay, so now I think I should change from there itself that I have discussed on that day. Yeah. So now the recent advancement in the solar drying technology for the sustainable development. Of course, in the drying, and in fact, the drying is not a new concept. We used to spread our foodstuffs in open sunny dry, on the floor when the sunny sky or sunny days are there. Okay, to dry the usually in the home. I remember at my home also, in my mother used to spread the this chili, red chili, or many things, papad, and many things were dried um, under the open sun drying. Okay, under the open sun. So success, it was, by that time it was very much success. And but at the same time, what happened, if suppose the radiations are very much strong, so you might have observed when we dry this chips, the potato chips, it colors are being changed. Okay, many times its colors becomes red instead of white. Okay, So sometimes it is overheating, and sometimes it is because
Sir,
of the
we have
what
now
the
only 5-10 minutes.
sir, only 5-10 minutes.
Yeah, you may take 15 minutes because
So
there is break time, but we have to give some
okay. After that, one more talk is there. Yeah. Why?
7:30 is another
mm,
talk.
okay, sir. Otherwise, we can stop so we can have discussion.
डिस्कशन
Uh,
करेंगे.
right, sir?
हाँ, briefly थोड़ा सा ये 2-4 मिनट
Okay, okay,
बता दीजिए,
okay, 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 okay,
because we
okay.
हमने रखना ही है,
Right.
0 hour in the parliament, so same is here.
Okay. Okay, sir. Okay. So actually, just I would like to highlight here the solar drying. Okay. So in the open solar drying system, of course, over drying is there, and many times the birds are, I suppose, flying over the paper, and some spice drying is taking place. Definitely, what will happen, a birds drain and unexpected rain storm dirt is there, so it definitely is degrade the quality. Okay. So it is the ancient, it was practiced since the ancient time. This open sun drying, the dryer or okay. So now the later people have realized the better to do some control conditions. The drying of the food stuff should be in the controlled conditions. So definitely its quality will be improved, and at the same time, the time what happened, because the most of the food product is the hygroscopic in nature. Okay. But in the sun is means rising in the morning and the evening. That means radiations are not uniform. Okay. In the noon, you will get the highest high level of highest solar radiations or the solar energy, but later on it will decrease. So if suppose one more thing, if suppose the if suppose the this moisture contains, or the relative humidity of the relative humidity of the environment or surrounding air is more, okay, then what will happen? Reverse phenomena will happen. So means that it will start absorbing. So such kind of the problems you can avoid with the help of solar dryers, right? So these dryers are classified open sun drying and solar. Of course, the open sun drying is also a solar drying. Okay, the cover drying, or say cover drying, or say solar drying. Okay, this active or passive mode. Active and passive mode. This means for the active you need to have some exhaust for the force flow. Exhaust fan or the blower is needed over there. And for the passive mode means all the hot and humid air is flowing with the by the concept of the thermosiphon effect. Okay. So now these are the active and passive. And in active, just you look at over here, if you could able to see this fan is providing over here. Okay, radiations are falling. This is the integral type of dryer. Okay. So this is insulated, this portion is insulated, and over here the glass is there. Okay, this is also glass, and the air is coming and rising. The ambient air is coming and rising because of the temperature gets rise. And this is a kind of the collectors. Okay, this is black painted collectors. Okay, air the ambient air comes, and when it comes in contact with this, it becomes light because of the temperature where it is higher, and it starts moving upward direction. And at the same time, what happened, through the glass or through the transparent surface, these radiations are coming. And over here, these are the different trays are placed over there. Okay, now this is over there means it is air is coming in this direction, and this blower or the fan is kept over there at the bottom. This is keeping it outside. Hot and humid air is coming and out with this way, like in this way, right? And this the flow is managed, or flow is controlled with the help of this blower itself. But in this case, just to see the chimney, the long chimney is made over there, right? So this is the proper designing of the chimney, so that the flow can also be maintained. So in the drying system, definitely the three parameters are very important. One is the temperature, airflow, and the relative humidity, because these three parameters are very much important operating parameters you have to maintain. and that the temperature, drying temperature, what could be drying temperature, that depends on the agriculture commodity, the which kind of commodity, which kind of fruit or vegetables you want to dry, that depends on that itself. Okay. So now this is the again the indirect type systems. Indirect type system or distributed indirect type system, what you have done in that flat plate collector is attached over there. Okay, so this is the flat plate collector and this is blower. The forced air is forced. Definitely, if collector is there, the lot of pressure drop is there. Okay, and thermosiphon effect. If suppose these trays are not properly designed, so the drying will not take place completely or properly. Okay, so in case of the passive design, just look at over here. This collector is attached over there. Air is coming inside, and flow is maintained with the height of this chimney. Okay, height and diameter of the chimney, and the flow is maintained. Flow inside this one. So now this is the mixed mode. In the mixed mode, what happened? And so this is the direct mode. In this mode, radiations are coming. Ultraviolet radiations are there. Shortwave radiations coming and falling on this surface. And now this is the indirect mode. Just to see the solar radiations are coming falling over there, and this is opaque surface. Okay, this is completely opaque surface. So air is heated indirectly and then passing through this drying chamber, and drying of the food stuff is taking place. And this is the flow is governed with the help of this chimney. Now the main the mixed mode, at the same time the indirect both the concept is applied over there. So in this case, of course, the fan is there for the proper flow inside this drying chamber, right? And so radiations are falling on the surface. This is not opaque. Okay, this is the transparent media. Okay, it could be the glass, it could be the polymer sheet, and the very good quality of the polymer sheets are available. And of course, the cost is less and more economic as compared to glass. And there are a lot of problem with the glass. Okay, transmissivity is matters over there, and okay, the very high transmissivity polymers are there. Polycarbonate sheet, for example, it is one of that. So now the collector is there, right? So air is heating indirectly as well as the radiations coming. So by that way, and fan is there. So broadly, you can classify the solar drying system with this way, based on receiving the solar energy and utilization, direct indirect way, and how the flow inside the drying chamber is maintained, active or passive drying system, right? So this is just the fundamental. I know you are faculty, and if suppose the students are there, definitely for them it will be useful to know the concept, right? The direct, indirect, and hybrid systems, and all. The broadly we can further we can classify like the greenhouse drying system. Okay, my most of the work is on the greenhouse drying system, and recently better, as sir has already instructed me, so I will skip and just what the work recently has been done in my lab, that this is our work as itself, Prakash and Kumar model. Right now, this Om Prakash is the assistant professor in BIT Mesra. He's doing very nice work. Okay, so recent publication based. Recently, we have published few papers based on Mr. Anand is working on that. Anand Kushwa, and two research paper within a year we published based on this system. Just some brief idea just I want to give you over here. So this basically this is the greenhouse drying system, and greenhouse drying system, two trays are placed over there. And this is in this greenhouse drying system, this is the polycarbonate based drying system, right? And its roofs are utilized. Roofs are utilized utilized for the installation of PV modules, and these PV modules are basically the transparent type modules are there. Okay, so that the radiations are also radiations are also allowed to come inside the drying systems. Okay, and this is the evacuated tubes collectors. So indirect heating, basically the trays, how to actually I don't have the diagram, and just to try to understand means trays are placed on the serpentine tubes are there. Serpentine tubes are there. On those serpentine tubes the drying trays are placed. Okay, so sorry, so all the means one is direct heating is there, direct solar radiation are utilizing for the drying this purpose, and another indirect heating is through the water. And water, and the study has been taking place for the different mass flow rate. Okay, for the different mass flow rate of the water, uh, it is a very successful design. And various, as I told you, the temperature, relative humidity, and airflow. These are the quality affecting parameter of dried product, right? So this has been the DC fans are are installed on the roof, on the top wall, means east wall basically. Okay, for maintaining its flow. Okay, a rotometer and all the temperature sensor, the thermocouple placed in the various places. And this and the water storage, because what happened, drying, this system was designed for the cloudy weathers also. Now you will say, okay, what will happen for the cloudy days, whether it is sustainable model or not. Of course it is sustainable. Okay, so this system was designed, if suppose the sun is not there for doing, it can work for 8 hours. 8 hours it is capable. And of course gradually its temperature will become very less, means decreases by because of the proper utilization of this. So this is the latest development. Let me read. If something developed, the fabrication of vacuum type solar collector integrated greenhouse drying system, moisture content of the mushroom. And mushroom, along with mushroom, we have done other product was derived. Mushroom kept in the solar drying reduced from 89 to 10% in the 18 sunshine hour, whereas it took the 38 hours to day in the same open and the practical. Okay, so this, just look at over here. If suppose in open sun drying, and because both the experiment has been conducted simultaneously in the for this to achieve the same moisture content, the 10%. For open sun, it took the 38, whereas in case of this system, the 8 sunshine hours. Okay, and this is totally, the system is a self-sustainable system. Okay, there is no dependency on the grid power, right? So this is and now we can have some discussion. If suppose some query or some discussions are there, then if I could able to answer you, then it will be better. So shall I stop, sir, now?
Thank you, sir. Thank you very much. You have taken exhaustive, not one, you have included 2 lectures.